video is about forms of linear equations. The point-slope form of the equation of a line is shown up there. Y minus y1 equals m times parentheses x minus x1. So m stands for the slope of the line. And then that x1, y1 is any point that's on the line. So if they give you a point, or if you're looking at a graph, you can use any point to replace x1 and y1 in the equation. So an example, it says, write an equation of the line with a slope of -2, so they're giving us m, that goes through the point 3, -1. So they're giving us all the information we need to fill into this formula. So we're going to start with the y minus. That first y has to stay in the equation. It needs to be there in the equation when you're done. So we just leave that as y. But the second y, the one that has a y subscript 1 on it, that's going to be the y value from our point. So that's going to be this y value here. Replace that with a -1. I'm just going to use parentheses because there was already subtraction there. Equals m, which stands for slope, and we have the slope. And then in parentheses x minus, and then the x subscript 1 is this, the 3, which is from our point. I'm just going to simplify the left side of this equation, because I don't like that minus and negative. Just change that to y plus 1. The right side of the equation, I'm going to leave it as it is, because it doesn't say what form I need to write it in, so I'm going to leave it just like this. This is point-slope form, and that's the equation of the line that has those two characteristics. The slope-intercept form, which is the most common form of the equation of a line, is y equals mx plus b, where m is still the slope, and now b, our new little constant there, is the y-coordinate of the y-intercept of the line. So that sounds complicated. It's not that complicated in reality. If you have a coordinate plane like that and a line that crosses the coordinate plane, the y-intercept is that point right there where it crosses the y-axis, and its coordinates are always going to be something like 0, 2, right? 0, something. In our first example, it says, write an equation of the line with a slope of -4. So it's giving us our m that goes through 0, 5. So you should recognize that right away as a y-intercept. So to write the equation of this line, we're just going to use slope-intercept form because we're given the slope, y equals -4x. That's the m in the equation, plus b. And b is the y-coordinate of the y-intercept, and it's a +5. So I just write +5. That's the equation of the line. Another thing you'll be asked to do pretty frequently is go between the two forms or three forms of linear equations. So this next example says, write the equation of that line that's given in slope-intercept form. And you should recognize the form that it's given in from the previous slide. It's point-slope form. So we're going to start with this, just going to rewrite it here, and try to get it in the form y equals mx plus b. And you'll see y equals mx plus b has no parentheses in it, and it has y by itself on the left side of the equation. So those are the two big things we need to change here. I'm going to start by getting rid of the parentheses using distribution. 1/2 times x is 1/2 x. 1/2 times that -5 is -5/2. I'm almost there, one step closer. Now I need to get the 4 off of the left side of the equation because the y has to be by itself over there. So I'm going to add 4 to both sides so that this side just has y on it now. 1/2 x doesn't change. Now I need to add the whole number 4 to the fraction 5/2. Since I need a common denominator here, I'm just going to write it next to it. I need it to be over 2, so it's going to be 8/2, right? If I did 8/2, that would be 4. So instead of doing that, I'm going to add 8/2. -5 plus 8 is +3, so plus 3/2. That is the same exact line written in slope-intercept form instead of point-slope form. The third form is called standard form. The standard form of the equation of a line is ax plus by equals c. A, b, and c are just integers. That means they have to be whole numbers, positive or negative. And we want a to be positive if possible. So that might just mean changing all the signs at the end of the problem. But it's definitely important that they all be integers and not fractions. So let's see an example. We're asked to write the equation of the line y equals 1/2 x minus 4 in standard form. So you should recognize that form as slope-intercept, and it's asking us to put it in standard form. I'll just rewrite it and then see what changes I need to make to it. So it looks like I can leave the y where it is, and I need to move the x term in front of the y term, so get it onto the left side of the equation. So I'm going to do that first. I'm going to move this x term to the front of the equation by subtracting it from the right. I'll put this left side in the order that I want it to be in, negative 1/2 x plus y equals negative 4. And now it's in the right order, but it doesn't meet the qualification that a, b, and c have to be all integers because we have that 1/2 there. So to make 1/2 be an integer, I'm going to multiply the entire equation by a 2. To keep it balanced, you have to do it to the whole equation. But by multiplying 2 by 1/2, we knock out the fraction and make that just negative x. This becomes 2y, and this becomes negative 8. It's the same equation, it's just scaled up by 2. And now it's in the right order, we're all integers, but I can easily make a positive here, so I'm going to do that by changing all the signs. X minus 2y equals positive 8. I'm essentially just multiplying both sides of the equation by a negative 1 there, which we're always allowed to do. And now my equation is in standard form. And that is all.